A fragment of lung tissue weighing just 350 milligrams sat frozen for more than 500 years before scientists finally extracted its DNA. What they found did not match the identity historians had assigned to the mummy for decades. High in the Andes, 5,300 meters above sea level, wrapped in textiles and locked in ice colder than most industrial freezers, a child's body waited in complete silence for a genetic secret no one expected. By the end of this video, you will know why a DNA test changed the identity of a 500-year-old mummy, what scientists discovered hidden inside his genetic code, and why that discovery is forcing researchers to rethink part of South American history. This discovery matters because it shows that history can survive for centuries inside a body while its true story remains completely hidden. By the end of this video, you will know exactly who this mummy was believed to be, exactly how a new generation of DNA analysis exposed a forgotten lineage, and exactly why experts say the result could rewrite what we know about the people who lived in the Andes before European contact. In the summer of 1985, mountaineers climbing Cerro Aconcagua in Argentina spotted something protruding from the frozen ground. At first it looked like debris. Then they realized it was human. The body belonged to a child. Archaeologists soon arrived and began a careful excavation. The mummy had been preserved by ice, wind, and altitude. He was estimated to be around 7 years old. Around him were ceremonial objects, miniature statues, and textiles associated with one of the most powerful civilizations in South American history, the Inca Empire. Everything about the burial seemed to point toward a familiar explanation, but a question remained buried beneath the ice. 5 centuries earlier, the Inca ruled a territory stretching nearly 4,000 kilometers along the spine of South America. Their roads crossed mountains, deserts, and valleys. Their armies controlled millions of people. One of their most sacred rituals was known as Capasaca. Children selected for the ceremony could travel hundreds of kilometers before reaching mountain summits. There, they were offered to the gods in ceremonies linked to politics, religion, and imperial power. The Aconcagua child appeared to fit this pattern perfectly. The burial location matched known ritual sites. The artifacts matched Inca traditions. The estimated age matched previous Capasaca victims. For nearly 30 years, researchers believed they knew exactly who this boy was. But belief and proof are not the same thing. The accepted explanation was straightforward. The child was an Inca sacrifice victim, from a population genetically similar to other indigenous groups living in the Andes at the time. His burial represented another example of imperial expansion during the final century before Spanish arrival. Case closed. Textbooks repeated it. Museum exhibits reflected it. Researchers cited it. Then genetic technology advanced far beyond what was available in 1985, and suddenly the mummy had a chance to speak for himself. In the early years of ancient DNA research, scientists often struggled with contamination. Modern DNA could mix with ancient samples. Tiny mistakes could ruin entire studies. By the 2010s, new sequencing techniques changed the field. A team led by geneticist Antonio Salas, working with researchers in Argentina and Spain, obtained permission to examine the Aconcagua mummy using advanced mitochondrial DNA sequencing. The sample came from lung tissue preserved inside the body. The scientists worked in controlled environments. Independent laboratories compared results. Contamination checks were performed repeatedly. Everything appeared routine, until the genetic profile appeared on the screen. Instead of confirming expectations, the DNA pointed somewhere no one anticipated. What if the biggest mystery was not who this child was, but an entire population that seems to have almost vanished from history? The accepted theory assumed the boy belonged to a well-documented genetic lineage, common throughout indigenous populations. But his DNA did not fit neatly into that picture. Researchers began comparing his genetic signature against databases containing tens of thousands of mitochondrial genomes. The search kept returning the same result. No close match. Then the implications became difficult to ignore. The first surprise involved the child's maternal ancestry. Scientists found that his DNA belonged to a branch of haplogroup C1b, one of the major Native American genetic lineages. But this branch was different. The specific subgroup, known as C1b, was so rare that researchers struggled to find living examples. After searching databases containing more than 28,000 mitochondrial genomes and over 150,000 genetic records, only a handful of related individuals appeared. The lineage existed, But barely. The boy was not genetically representative of the population historians expected. He belonged to something far rarer. The second discovery was larger. Genetic modeling suggested this lineage may have emerged roughly 14,000 years ago. That places its origins thousands of years before the rise of the Inca Empire, long before cities, long before kingdoms, long before recorded history in the region. Researchers found hints of the same lineage among a few populations in Peru and Bolivia, but only faint traces remained. It was as if the mummy preserved evidence of a branch of humanity that had once been more widespread before slowly disappearing through migration, population collapse, or assimilation. Suddenly, the child was no longer just an Inca sacrifice victim. He was evidence of a forgotten human story. The third revelation changed the meaning of the entire discovery. For decades, historians reconstructed ancient populations using artifacts, architecture, language, and written records. But DNA introduced a new source of evidence, a biological archive. The Aconcagua mummy showed that entire genetic lineages can fade from the modern world while surviving inside ancient remains. Populations that appear invisible today may once have shaped civilizations, migrations, and cultures across continents. The boy's body had preserved more than tissue. It preserved a warning. History is not a complete record. Civilizations rise. Languages disappear, kingdoms collapse, entire family lines can shrink until only fragments remain. Yet beneath layers of ice, sand, and stone, traces survive for centuries, waiting for technology capable of finding them. And if one child can reveal a nearly forgotten lineage after 500 years, how many others remain hidden beneath mountains, deserts, and caves around the world? The publication of the genetic findings drew attention from archaeologists, anthropologists, and population geneticists. Many researchers focused on what the study revealed about genetic diversity before European contact. Others emphasized the importance of ancient DNA in correcting assumptions based solely on archaeology. The reaction was cautious but significant. The mummy had not overturned everything historians knew, but it had exposed a missing piece. And sometimes a missing piece changes the entire picture. A DNA test on a 500-year-old mummy revealed that a child long believed to represent a familiar Inca lineage actually carried one of the rarest genetic signatures ever found in the Andes. But one question remains. If this lineage was once more common, what happened to the people who carried it? And how many other forgotten branches of human history are still waiting to be discovered? Share your theory in the comments. Click the next video on your screen for another discovery that will leave you questioning everything.